Okay, let's do this statistics question here. We're going to try and compare the math marks and the physics marks, of 8 students. And all you've got to do, well, first let's read the first question. Which student's result could be considered an outlier? Well, that guy is out in the left field or something. It's definitely an outlier. It's not, doesn't, all the other ones look like they go along a line, really. Gee, it'd be really close. It might be smart to remove it. But the next question says, determine the correlation coefficient for 8 sets of data. So for 8 students. So, okay, so we're going to include it in the data. So what do? We go to our a plus bx, because that's how we get correlation coefficients and least regression stuff. And we put in these numbers for x, and we put in these numbers for y. And then we press AC, we clear it, and we check it carefully, make sure we get the numbers in, and then we go Shift, Stat, and then Regression, REG, I think it's number 5. And 3 letters will come up that we need. One of them is the correlation coefficient here they ask about, and it's 0.77. So that's moderately strong. If we call 0.5 moderate, then moderately strong would be 0.77. It's not really strong, but it's moderately strong. That's reasonable. And why can we see why is it student number 4? Because it's at 50 here. So it must be the 38 and 50 that's an outlier. Okay, how can we make the equation of least squares regression line? Well, we've got our data in. We just go Shift Stat, press REG, and then look for A, and hit the number that goes with A, and you'll get this negative 10.8 if you round it off. That is the y-intercept. And then the gradient goes in front of x. And if you round it off, you'll get 1.08. Okay, so there's your equation of the least squares regression line. All done. There you go.